Question says that given in figure 5.11 are example of some potential energy functions in one dimension. The total energy of a particle is indicated by cross on the ordinate axis. Here ordinate axis is the y-axis and this is the total energy. Now if we want to see the total energy in this plot, then we can simply draw a horizontal line cross that is passing from that cross, so we can now know for each point what is the total energy. It is easy to visualize. In each case, specify the reason, if any, in which the particle cannot be found for a given energy. So we have to specify which among the given regions, like in this region x-axis is divided in two regions, a less than a and greater than a, and in this less than a, between a and c, between c and b, between b and d. So we have to specify in which region does the particle can never exist given the energy level of the particle. We also need to indicate the total energy of the particle that the particle must have in each case. Now think of some simple physical contexts for which these potential energy shapes are relevant. So let us recap about the total energy. So total energy can be expressed as summation of kinetic energy and potential energy. We all know the expression of kinetic energy as half mv square. Now in no matter what the velocity is, it is never going to be negative. So now we are remained with potential energy. So total energy, if we have to find out the minimum total energy, then what we can do is simply minimize this kinetic energy to 0. Then we can indicate total energy as equal to potential energy. So the second part of question, as it is saying that also indicate the minimum total energy of the particle that the particle must have in each case. So in those cases we can use this that total energy of the particle is equals to minimum potential energy, because the minimum kinetic energy can be is 0. So also for the reason to be valid in the terms of energy, let us subtract the potential energy from kinetic energy from the total energy. So total energy minus potential energy is equals to kinetic energy. Now we can see that left hand side can never be less than 0 because it is equal to kinetic energy, and kinetic energy can never be less than 0. So total energy minus potential energy can always be greater than or equal to 0. Now using this expression we can find out whether the reason is valid or not. So let us see the first question. Here total energy is this line, and the reason from after A, we can see that the given energy level is greater than total energy, or the potential energy is V0, that is of magnitude greater than E. So here what we see here is, using this expression, is that this expression will turn out to be negative, because total energy should always be greater than or equal to potential energy. Here total energy is less than the potential energy, that is this line is above than the red line. So the reason from A to beyond is going to be invalid, or the particle cannot be found in the given energy for the reason x greater than A. So for region x greater than A, it is going to have no particle, and also the minimum total energy of the particle can be, so before point A it is 0. So the minimum total energy of the particle that the particle can have is just equal to potential energy, and that is equals to 0. So we can say it is 0. Now in second question we have the total energy. Let us draw a horizontal line again. So here we see that for the entire region, the total energy, potential energy is greater than the total energy. Now it again contradicts this expression. So we can say that for no reason, for all the reasons, the particle cannot be found in the given energy state. So from minus infinity to plus infinity, the particle is going to have zero energy. The particle can't be found. Now the minimum total energy that the particle can have is, let us represent this magnitude as V1. So it is going to be V1. Now proceeding to the next question, we have, so here total energy is crossing the potential energy at 2 points, minus b by 2 and plus b by 2. So using this expression, total energy can only be greater than or equal to potential energy. We can say that for the region x, for the region between minus b by 2 to minus a by 2, the particle can't be found because here total energy is less than the potential energy. So for region x greater than minus b by 2 to minus a by 2, the particle can't be found, and also for region a by 2 to b by 2. Now the minimum total energy that the particle can have is, again we can use this expression. The minimum total energy that the particle can have is equals to potential energy, the lowest potential energy. So it is going to be equal to minus V1. Now in fourth, we have again the total energy. Let's draw the line. So we can see that the region from x less than a and the region beyond b lie above the total energy line. So we can say that the particle can't be found there. So for x less than a and x greater than b, particle can't be found. And also the minimum total energy that the particle can have is minus of V1.